So, we are discussing about the clustering algorithms, and in the last class what we discussed is what is called agglomerative clustering, and we have seen that agglomerative clustering is nothing but a hierarchical procedure which is a bottom up procedure, where in every step two most similar clusters will be merged together to form a single cluster. And we have seen that if there are say n number of points, then if you follow this agglomerative clustering, where in every step you merge two most similar clusters, then after n minus 1 number of steps, all the points or all the feature vectors are put into the same group. Okay. So, there we can have one of the two approaches, that is we can either decide that what should be the distance threshold between two clusters, so that they can be merged into a single cluster, or they are to be separated and considered separately to form two separate clusters. And based on that we can decide about how many clusters we will have, where I do not have any control over the number of clusters, but it is the distance between the two clusters which will decide that what will be the two clusters or what will be the number of clusters. The other one can be that we can decide about that how many clusters we want to form out of a given set of feature vectors. So, depending upon that we can stop our agglomeration process or merging process at a particular step, where I obtain the desired number of clusters. And when we talked about this agglomerative clustering, we have also talked about three or four different types of agglomerative clustering. One of them was single linkage, that is the distance between the two clusters are defined to be the distance between two nearest points, one from one cluster and the other one from the other cluster. That is what is single linkage clustering. Then other one was complete linkage clustering, where the distance between two clusters was defined to be the distance between two farthest points, where one point is taken from one cluster and the other point is taken from another cluster. And we had also talked about average linkage, where the distance between two clusters is taken as the average distance of the pair of points, where one of the pair is taken from one cluster and the other one of that pair is taken from other cluster. So, that gives you the average distance between two clusters. And the other kind of algorithm that we also have talked about is that while doing this agglomerative clustering, it tries to find out a cluster where the variance is minimum. That is, given a mean vector of a particular cluster, variance within that cluster is the variance considering all the points put into that cluster. And we have seen that this variance is something which is related to the error within the cluster. And then we have defined about the total error, which is the sum of the errors of individual clusters. And this method, or Ward's method as we have said, tries to form the clusters where the total amount of error of clustering will be minimum. Okay. And we have also said that what is the nature of the clusters that you get when I use this different types of clustering. So, for example, in case of single linkage clustering, the cluster can be quite spread, because the distance between the two clusters is taken as the minimum distance of the pair of points. Okay. So, if I have a linear set of feature vectors is something like this, suppose this is one set of feature vectors and the other set of feature vectors is something like this. Okay. Then as single linkage algorithm tries to find out the distance between the nearest pair of points. So, you find that the distance between these 2 points will be minimum, and this may be below the threshold. Okay. So, in which case this entire set of points will be put into a single cluster, okay, which will be avoided in case of complete linkage, because complete linkage tries to find out what is the distance between this point and this point. Okay. So, that is the distance between two farthest points. So, taking that, the single linkage algorithm will try to avoid this sort of clustering, rather it will try to find out clusters which are more compact. Okay. And the average linkage is something in between the single linkage and the complete linkage. And of course, what Ward's method tries to find out is also a cluster where the cluster is quite compact. Okay. Now, today what we are going to discuss about is what is called Batchelor and Wilkins algorithm. So, in case of Batchelor and Wilkins algorithm, it is also a sequential process. What you do is you take the first feature vector and assume the first feature vector to be one of the cluster centers. Okay. Then try to find out the distances of all other feature vectors from that first feature vector. So, what we can say is, so given a set of feature vectors, so I have n number of feature vectors which are say x 1, x 2 up to x n. So, what I will do is, one of these feature vectors I will take arbitrarily and assume that to be the first cluster center. So, I can assume that the first feature vector which I will take is x 1, and suppose this point x 1 is the cluster center or the of the first cluster, which is z 1. Okay. Then find out the distance of all other feature vectors from this z 1. Take the furthest point or the furthest feature vector whose distance from z 1 is maximum and assume that to be the second cluster center. Okay. That can be any of the other feature vectors from this set. Okay. So, suppose that is x I and say that is my second cluster center, which is z 2. Now, given these two cluster centers, you try to find out the distances of all other feature vectors from these two cluster centers, right. So, given any other point say x j, I want to find out what is the distance between x j and z 1. I will also find out what is the distance between x j and z 2. Okay. I will consider the distance which is minimum of these two. Okay. So, for every point other than these two x 1 and say x I, which happen to be the second cluster center, for all other points I find out the distances from z 1 and z 2, and I consider that distance which is minimum among the two, and that is computed for all other points. Okay. And out of these minimum distances, I find out what is the maximum distance. Okay. So, it is like first I find out minimum of d x j z 1 and d x j z 2. Okay. Then I find out what is the maximum of these distances, where this maximum is over j. Okay. So, whichever x j gives this maximum value, if that distance is greater than an appreciable fraction of the distance between z 1 and z 2. Okay. So, if this d x j or say this distance, if this is greater than some fraction tau times distance between z 1 and z 2, then the corresponding x j I assume to be the third cluster center. Okay. And this process continues. So, once I get the third cluster center, for all other points I have to find out what is the distance from z 1, what is the distance from z 2, what is the distance from z 3, which is the third cluster center. And out of these three distances, I have to take the minimum. Okay. So, such minimum distances I have to compute for all other points, and out of these minimum distances I have to find out the maximum. And if this maximum distance is greater than certain fraction of the minimum of dz 1, dz 2, dz 1 z 2, dz 2 z 3 and dz 1 z 3, then that corresponding point x j I consider to be the fourth cluster center. Okay. So, this way it continues until and unless the distance or the maximum of that minimum distances becomes less than that threshold which is defined. Okay. So, at that point I can stop my clustering, and once I stop my clustering, till that point what I have decided is how many cluster centers I have. So, once I have those cluster centers, then remaining points are simply put into one of those clusters based on minimum distance criteria. Okay. So, if I simply go by this distance threshold, I do not have any control over the number of clusters that I form, or otherwise what I can do is, if I want 3 clusters, I can stop when I get 3 cluster centers, and the remaining points is put into one of those 3 clusters based on minimum distance criteria. If I want 4 clusters, I will stop when I obtain 4 cluster centers, and remaining points will simply be put into one of those 4 clusters based on minimum distance criteria. Okay. So, that is what is called Batchelor and Wilkins algorithm, where by defining what will be my stopping criteria, either I can have a predefined number of clusters, or I can have variable number of clusters, where I define that what is my criteria for the distance between 2 cluster centers. Okay. So, let us take an example. Suppose I consider a number of points where, say, point A is given by feature vector, say 1 1, point B is given by feature vector 1 2, point C is given by feature vector, say 3 2, point D given by feature vector, say 3 3, point E is given by feature vector, say 6 6, point F is given by feature vector 6 7, G is given by feature vector, say 7 6, So, these are the feature vectors which are to be clustered into various clusters. Okay. And I assume that the first cluster center I consider is the point A corresponding to the feature vector 1 1. Okay. So, as I said that once I use this Batchelor and Wilkins algorithm, from A I have to compute the distances of all other points. Okay. And these distances will continue in next steps. So, what we can do is we can form a distance matrix, or the distance matrix will tell me that what is the distance between a pair of feature vectors. Okay. So, what I will form is I will form a distance matrix to compute the distances between every pair of feature vectors. Okay. So, I have feature vectors A, B, C, D, E, F, G, H, I, J, K. Similarly, on the column also I write A, B, C, D, E, F, G, H, I, J and K. Okay. So, naturally the distance between A same point. So, this distance value will be 0. Similarly, B this will also be 0. Okay. Now, you find out the distance between A and B, and let us assume that we want to compute the Euclidean distance. Okay. So, here you find that the feature vector A, which has the vector 1 1, and B has the feature vector 1 2. So, naturally the Euclidean distance between A and B is 1. Okay. So, the distance between A and B, it is, let us write 1.0. Okay. Similarly, I can also compute the distance between A and C. There is 1 1, there is 3 2. I can simply compute the Euclidean distance. So, likewise, I can compute the Euclidean distance between every pair of feature vectors. Okay. So, if I complete this distance matrix, the distance matrix will be something like this. Between A and C, it will be 2.2. I will go up to the first digit. Okay. Then between A and D, it will be 2.8. Between A and E, it is 7.0. It is actually 7.07, but I am putting 7.0. Okay. A and F, it will be 7.8. Between A and G, it will be 7.8 again. Between A and H, it will be 8.48. A and I, it is 6.0. Between A and J, again 7.07. I am writing 7.0. Between A and K, it is 8.0. Okay. So, between B and A, it will be same 1.0. Between B and C, it will be 2.0. Between B and D, it will be 2.23. I am writing 2.2. Between B and E, it is 6.4. Between B and F, it is 7.07. So, I am writing 7.0. Between B and G, again 7.07. Between B and H, it will be 7.8. B and I, it is again 6.08. B and J, it is 7.0, and B and K, it is 8.06. Between C and D is same as A and C, so it will be 2.2. Between B and C, it is same as this 2.0. Between C and D, the distance is 1.0. Between C and E, the distance is 5.0. Between C and F, the distance is 4.89. Let me write it as 4.9. Between C and G, the distance is 5.6. Between C and H, the distance is 6.4. Between C and I, the distance will be 4.1. Then the distance is 5.0, and the distance will be 6.08. Then when I compute the distance from D, it is 2.8, then comes 2.2, actually 2.23, then 1.0, then D and E, it is 4.2, D and F, this will be 5.0, then D and G, again it will be 5.0. Between D and H, the distance will be 5.6. Between D and I, the distance will be 4.47. So, let me write it as 4.5, then 5.09, and then the distance is 6.32. So, like this I can complete this distance matrix. Okay. I am not going for all the entries, and once you complete this distance matrix, you have to find out that what we have done is initially we have assumed that my first point A, that is the first cluster center Z 1. Okay. So, I have to find out a point, a feature vector which is furthest from A, and the furthest feature vector I will get from the first row, which is having the maximum distance. And here you find that out of all these, the maximum distance is the distance of the feature vector H. Okay. So, this becomes my second cluster center. So, the first cluster center that I have is the feature vector A, and the second cluster center is the feature vector H. Okay. So, once I have these two feature vectors or these two cluster centers, I have to compute the distances of all other points from these two cluster centers. So, other points that I have are point B, C, D, E, F, G, H is a cluster center, okay. Then I, J, K. Okay. So, if I compute the distance between A and B, the distance I will simply get from this matrix. Once I have this complete matrix, I will get this distance from this matrix itself. Okay. So, the distance between A and B is 1.0, and the distance between B and H again I will get from this matrix, which is 7.8. Okay. And as I said that I have to take the minimum of these two, and the minimum is nothing but this one. Okay. Similarly, I have to compute the distance between C and A and C and H. Okay. So, the distance between C and A will be 2.2 or 2.23, which I have put as 2.2, and the distance between C and H again I can compute from here, which is 6.4. Okay. So, this distance is 6.4. Again I have to take minimum of these two. So, the minimum distance is 2.2. Okay. Between D and A and D and H, the distances are 2.8 and 5.6. Okay. Again the minimum distance is 2.8, because I am always considering the minimum of this pair of distances. Then when I consider point E, the distance between E and A is 7.07, and between E and H the distance is 1.41. Okay. So, here the minimum distance is 1.41. So, I have to consider this distance. Similarly, when I compute between F and A, the distance between F and A is 7.8 or 7.81, and here the distance is 1.0. Between G and A, the distance again is 7.81, and here the distance is 1.0. Between I and A, the distance is 6.0, here also it is 6.0. So, you find that both these distances are same, that is point I is equidistant from A and H. So, I can consider any of them. For J, it is 7.07 and it is 5.09. For K, it is 8.0 and 6.32. Okay. So, when I consider all the minimum distances, here the minimum distance is this, here the minimum distance is this, here I can take any of them. So, let me take this one. Okay. Here the minimum distance is this, and here the minimum distance is this. Okay. So, So, these are the minimum distances that I have, and then what I said is I have to take that point where for which this minimum distance is maximum. Okay. So, you find that that is point k. So, this point k will be taken as the second cluster center, third cluster center. My first cluster center was A, second cluster center was H, and the third cluster center is K. Okay. So, once I have this third cluster center, let me include this third cluster center also. So, I want to find out the distances from all these points from the point K as well. Okay. So, when I do that, the distance between B and K, I already have distance between B and A and B and H. Okay. So, I have to compute the distance between B and K, and distance between B and K, that comes out to be 8.06, distance between C and K, that comes out to be 6.08, between D and K, the distance comes out to be 6.32, E and K, it comes out to be 5.83, between F and K, it comes out to be 6.70, between G and K, the distance comes out to be 5.38, between I and K, the distance comes out to be 2.0, between J and K, the distance comes out to be 1.41. Okay. So, now find that once I have all these different distances, now again when I take the minimum in for each of these distances, in the first case the minimum remains as 1.0, minimum of all these three distances. In the second case also the minimum remains to be 2.2, third case also the minimum remains to be 2.8, here the minimum remains to be 1.4, here the minimum remains to be 1.0, here also it is 1.0, here now 6.0 is no more the minimum distance, but the minimum distance is 2.0. So, this is not the minimum anymore, the minimum distance is 2.0, right. Similarly, over here the minimum distance is 1.41. Okay. This is no more important because K has already become a cluster center. So, if I decide that I will stop my clustering at this point when I have three different clusters, then I have one cluster center which is A, the second cluster center which is H, and the third cluster center which is K. So, given these three cluster centers, I have to cluster the remaining points to one of these clusters whichever is nearest. Okay. So, naturally that information I get from this particular table. The distance between B and A is minimum among these three distances. So, naturally B will be put into cluster formed by this cluster center A. Similarly, C will be put into the cluster formed by cluster center A. D will also be put into the cluster formed by cluster center A. Coming to E, you find that the distance between E and H is minimum. Okay. So, the point E will be put into the cluster formed by cluster center H, F similarly will go to the same cluster, G will also go to the same cluster. Okay. Coming to point I, the distance between I and K, that is minimum. So, point I will go to the cluster of cluster center K, similarly point J also will go to the cluster formed by cluster center K. Okay. So, I get three different clusters. One cluster contains point A, B, C and D. This becomes one cluster. The second cluster is H, E, F and G, and the third cluster is K, I and J. Okay. So, these are the three clusters that is formed by following this Batchelor and Wilkins algorithm. Now, here you find that when I have used this Batchelor and Wilkins algorithm, the Batchelor and Wilkins algorithm, the output is likely to depend on the first feature vector which I used as cluster center. Because instead of using A as the first feature vector, if I use any other point, say E, then the clustering output might have been different from these three different clusters. Okay. So, because it is a sequential algorithm, so naturally the final output that I get is likely to depend on the type of or which of the feature vectors is taken as the first feature vector or taken as the first cluster center, because all other cluster centers are decided based on the first cluster center. Okay. So, that is one of the drawback of this Batchelor and Wilkins algorithm. Now, the other algorithm which can be formed out of this distance matrix, that is a graph based algorithm. Or graph based clustering. Okay. Now, what is this graph based clustering? I hope all of you know what is graph. Okay. A graph G is defined as collection of vertices and edges, or collection of nodes and edges. So, what I can do is, given the feature vectors, every feature vector can be considered to be a vertex or a node in the graph. Okay. And two nodes in the graph will have an edge, or there will be a connectivity between one node and another node depending upon the distance between those two nodes. So, if I put some threshold on the distance, then I can say whether the two nodes are connected or two nodes are similar or not. Okay. If the distance is more than the threshold, I will say that the two nodes are not similar. That means those two nodes are not connected. So, accordingly, in the set of edges, I will not have an edge in between those two vertices. Okay. And there are various ways of representing a graph. One of the way of representation of a graph is by a similarity matrix. Okay. So, similarity matrix is again a two dimensional matrix. So, if I have n number of nodes in the graph, then the similarity matrix is an n by n matrix. Okay. Where in every element in this n by n matrix, if for this matrix the element I j that is equal to 1, this indicates that node V I and node V j, they are connected. Okay. And in our case, if node V I and node V j are connected, that means the feature vector I and the feature vector j, they are similar. So, if they are similar, they should be put into the same cluster. Okay. So, for this graph based clustering algorithm, the graphical representation of the feature vectors that we have, that will be represented by a similarity matrix, where an element in the similarity matrix can have a value either 0 or 1. So, if the two feature vectors are similar or the distance between them is less than certain threshold, then I will say that those two feature vectors are similar, and accordingly I will have an edge between those two nodes. And if the distance between those two feature vectors is greater than the threshold, then I will say that those two nodes or those two feature vectors are not connected, and correspondingly the element within the similarity matrix will be equal to 0. Okay. So, when I go for clustering using this similarity matrix, what can be done is, I can take a row in this similarity matrix which has got maximum number of ones. That is, maximum number of feature vectors are put into a single cluster. Okay. So, I will take a row with maximum number of ones Okay. And I consider all other nodes. Okay. So, a point or a feature vector k will be put into the same cluster if I find that in the similarity matrix S j k is equal to 1, where the jth feature vector is already in the cluster. So, that is the relation of transitivity. Okay. So, if jth feature vector is similar to I, similar to a feature vector I, and kth feature vector is similar to jth feature vector, then by transitivity the kth feature vector is also similar to ith feature vector. Okay. So, when I take a row with maximum number of ones and all the corresponding feature vectors are put into a single cluster, okay, then I consider every point in that cluster, come to the corresponding row in my similarity matrix. All other locations or all other points which has got a 1 in the corresponding row, those feature vectors will also be put into the same same cluster. And following this, once I cannot grow the cluster anymore, then one of the cluster formation is complete. Okay. Then I have to repeat the same operation with the other rows and columns of that similarity matrix. So, the rows and columns corresponding to the feature vectors which are already put into a cluster, they will be removed, and with the remaining rows and columns I have to repeat the same operation to form the next cluster, and this will continue until and unless all rows and columns in your similarity matrix is complete. Okay. So, if I take the same example, that is the same set of feature vectors which I have considered for Batchelor and Wilkins algorithm, okay, and once I form for these feature vectors this type of distance matrix, okay, it is quite straightforward to form the similarity matrix from this distance matrix, because within this any distance value which is less than or equal to threshold, the corresponding element in my similarity matrix will be equal to 1. Wherever the distance is greater than the threshold, the corresponding element in the similarity matrix will be equal to 0. Okay. So, it is quite straightforward. So, if I form such a similarity, this distance matrix I did not complete. Okay. You can find out the distance between pair of feature vectors and complete this distance matrix. Once you have this distance matrix, then I can form a similarity matrix for the graphical representation of the same set of feature vectors. Okay. So, let me write the similarity matrix. So, I have the feature vectors A, B, C, D, E, F, G, H, I, J, K, and so let me complete this similarity matrix. So, as before, the distance between, when I take this pair A, obviously the distance is 0. Okay. So, by default the corresponding elements in the similarity matrix will be equal to 1, because here the distance value is 0, obviously it is less than or equal to threshold. Okay. Now, while forming this similarity matrix from this distance matrix, I assume my threshold to be equal to 2. That is, if the distance between 2 points x I and x j is less than or equal to 2, then correspondingly S I j will be equal to 1. Okay. So, my threshold I am taking equal to 2. So, considering this, your similarity matrix will be something like this: 1, sorry, there is a mistake. Okay. Okay. So, the similarity matrix will be something like this. So, as I said, when you start your clustering operation, clustering algorithm, I have to consider a row within this similarity matrix which has got maximum number of ones. Okay. So, you find that within this, the first one which has got maximum number of ones is the row E, okay, which has got 4 ones. Okay. And here E, F, G and H, all these will be put into a single cluster. Okay. So, E, F, G and H, all of them will be put into a single cluster. Come to the row corresponding to F, all the corresponding feature vectors within this row where I have 1 in the similarity matrix, they will be put into the same cluster. Okay. But you find that all the points in corresponding to which this entry is equal to 1, they are already put into the same cluster. So, nothing more is to be added. Next, you come to the row corresponding to G. Here also the same thing, all these points are already in the cluster. So, nothing more is to be added. Come to the row corresponding to H, again I have the same situation, that all these points are put into the same cluster. So, nothing more is to be added. Okay. And here I have considered the rows corresponding to all other points which are put into the same cluster. That means, one clustering is already complete. Okay. I cannot put any other point into the same cluster, because following these points I cannot move to any other row. So, this forms one of the clusters. Once that is done, I remove all the rows and columns corresponding to these nodes or these vertices which are already put into a single cluster. So, the rows corresponding to E, F, G and H, they are to be removed from this similarity matrix. So, I will remove all these rows and I will remove all the columns corresponding to E, F, G and H. So, I do not have to consider these rows and columns for any more clustering operation. Next, out of the remaining rows and columns, I have to repeat the same operation. So, I have to find out which of these rows contains maximum number of ones. So, if I start from the beginning, you will find that row B, it contains 3 ones, which is maximum. So, in the second cluster, I will have B, A and C. So, A, B and C, they will be put in one cluster. And I have considered row B. So, this row, the row corresponding to B is already considered. I have to come to row corresponding to this feature vector A, okay, and I have to put into the same cluster all the points where I have a 1 in this row. So, those points are A and B, which are already included. So, from this row of A, I cannot add any other feature vector into this cluster. Come to the row corresponding to feature vector C, you find that B is already included, C is already included. There is another feature vector which is not included. So, that is equal to D. So, I have to include D into the same cluster. Okay. And once D is included, then I have to come to the row corresponding to D, where C and D, which are already included. Okay. So, this cluster cannot be expanded any further. So, that second cluster which is formed is A, B, C and D. Okay. So, once I get this cluster, I have to remove the rows and columns corresponding to A, B, C and D. From the feature vector. So, what is remaining is this. Okay. So, here you find that following the same logic, all these points will be put into the same cluster. So, the third cluster is formed by I, J and K. Okay. So, I get 3 clusters. One cluster contains A, B, C, D. The second cluster contains point E, F, G, H, and the third cluster contains points I, J and K. Now, incidentally, this cluster that I have got is same as the cluster that was obtained using Batchelor and Wilkins algorithm, but this is accidental. I may not get the same one. Okay. But one thing is guaranteed in case of this graph based clustering is that, because when I go for this graph based clustering approach, I am considering all the points together. It is not a sequential one, because when I form the similarity matrix is formed by considering all the points together. That means, the output of the graph based algorithm, once I decide about this threshold, is unique. Okay. Just for algorithmic convenience, we have said that we have to first consider the row which has got maximum number of ones. But even if I do not consider the row which has got maximum number of ones first, my final output will not change. Even if I had considered this row A first, say A and B will be put into the same cluster. Come to point B, point C will be put into the same cluster, A, B, C. Come to the row corresponding to C, D will also be put into the same cluster. come to the row corresponding to this, the feature vector D, I cannot put any other point into this cluster. So, A, B, C, D becomes one's cluster. You remove the rows corresponding to this feature vectors A, B, C and D, next you come to point E. And following this, this is the cluster that I can form. I cannot form any other cluster. Remove all the rows and columns corresponding to E, F, G and H, what will be left out is only this. Okay. So, these remaining 3 points I, J and K, that form another cluster. So, whichever row I considered first out of this similarity matrix to start my clustering operation, that does not influence what will be my final set of clusters, because this clustering is done using the similarity matrix, where similarity matrix is a global information for the graphical representation of the given set of feature vectors. So, my clustering output will remain the same. What will matter is the distance threshold, because depending upon the distance threshold, I will have different types of similarity matrix. Okay. So, instead of taking threshold value equal to 2, if I take threshold value equal to 1, I would have got more number of clusters. Okay. If I increase this, instead of 2, if I take this threshold to be 5, then I will have more number of ones in this similarity matrix. Okay. And if I get more number of ones in this similarity matrix, that means in a single cluster I will accumulate more and more number of points. So, effectively the number of clusters will reduce, where the size of individual cluster will be quite big. So, if I go for this graph based algorithm, what decides the final cluster output is the threshold that I consider. It does not depend upon in which order I go for clustering the points, unlike in case of Batchelor and Wilkins algorithm. Okay. So, I will stop here today. Next day, I will start with some other algorithms for clustering techniques.